Hey Bobcats, welcome back to Algebra 1. Today's edition, we are finding a geometric sequence, okay? Geometric sequence, what is that? Well, we're just going to look and determine another way that sequences can count for us. So, taking a look here, we got Ben, he's got a sequence, Sven, he's got a sequence, and Glenn, he's got a sequence. So, what is Ben's sequence? Well, I got 20, 40, 60, 80, 100. Hopefully, you're able to determine that that is a common difference and that we're adding 20, right? For Sven, we are adding 2, 4, 6, 8, 10, right? So we're adding 2 each time. So that's the common difference there. However, from 8 to 16, that's 8, but I don't add 8 to get to 32. So what's happening here? Well, hopefully you can notice that now I am no longer adding or subtracting, but what I'm doing is I am multiplying. That's right. Multiplying times 2 to get to the next term. So we say that this is R is equal to 2. R? What is R? Well, R is what we call a common ratio. Why is it a common ratio? Because if you're not sure how this is working, you take 16 and you divide it by the number previous. So there's your common ratio. Right? I could take 32 and divide it by the previous, and it would still give me 2. So in other words, if I take 8 and I multiply it by 2, and then multiply that by 2, and then multiply that by 2, it just keeps happening over and over again because all I'm doing is multiplying this by 2. Okay? So that's a common ratio instead of a common difference. All right, so let's take a look at an actual geometric sequence. Is this a geometric sequence? Well, yes, it is. How do I know? Well, because I start with 3, and if I'm going to this term here, I'm multiplying by 2. And if I multiply by 2 again, I get 12. And if I multiply by 2 again, I get 24. So my ratio is times 2 here. A sub 1, hey, it's the same it was yesterday, right? This is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and so on, right? So each term in the sequence is considered a sub 1, that's the first term, which is 3. A sub 3, which is 12, that's our third term. Now, what would be the next 3 terms? Okay, well, we know that 48, right? And if I multiply that by 2, then that's going to give me the next term, 96. And then if I multiply that by 2, that's going to give me 192. And then if I multiply that by 2, it'll give me 384. So, hopefully that's making a little bit more sense right there. Let's take a look at another example. So, say that we're given this, right? Is this geometric? I don't know. Let's check. How do I check? Take 25 and divide it by 125. 0.2. What is that? 1/5. So we're saying if I take 125 and I multiply it by 1/5, is that 25? Cool. What about if I multiply that by 1/5? That gives me 5. And if I multiply that by 1/5, whoops, that gives me 1. So what's happening here each time we do this is that we're multiplying by 1/5. So my R value is equal to 1 over 5. A sub 1, that's my first guy in the sequence, 125. A sub 3, that's my 5. He's the third term in the sequence. And it wants to know what is A sub 0. Well, how do I go back? Well, if I'm multiplying by 1/5 there, think about this, right? If I take 1 and I multiply this way to 5, it gives me 5. If I multiply that by 5, it gives me 25. If I multiply that by 5, it gives me 125. So if I multiply 125 by 5, I get 625. 625. So why is that helpful? Well, finding A sub 0 is super helpful because it helps us find any term, okay? What do I mean by that? That means we can find any term. Now let's go back to the 1. If I want to multiply and find what the next number is in the sequence, right? That's 0.2 or 1/5. right? And then if I multiply this by 1/5, then I get 1, 25. And if I multiply that by 1/5, I get the third term that would happen. So here's my next 3 terms in the sequence, okay? Now, if I want to find any term, all I need is a sub 0 and my r value, and then I raise that to the power of x. So in other words, if I know what a sub 0 is, in this case it's 625, and if I know what my common ratio is, in this case it's 1/5, and then if I raise that to the power of x, I should be able to generate any term. So as long as I know a sub 0 and r. So let's check it out. If I take 625 to the 1/5, whoops, arrow over, and raise that to the power of x, and I turn this to a table, is this what I need? Is the first number 625, or the first term of the sequence 125, and then 25? And so if I go to 3 and I hit enter, at 3 is 5, the next one's 1, then 0.2, then 0.04, and 0.08. Well, wait a minute, what is 0.04? You said 0.04. Isn't 0.04 1/25? So this is how you would find, again, this is what you need to find any term. A sub 0 and your common ratio. All right, guys, thanks for watching. We'll check you next time.